A router can run out of memory even when every receive buffer is eventually freed. On this MX4200, Wi-Fi traffic drove memory towards zero, while ath11k's receive inventory stayed bounded. The problem was not a growing queue, but small buffers pinning much larger physical pages. To receive a packet, ath11k allocates an empty socket buffer, DMA maps it, records its ID, and posts its address into a circular RxDM, a refill ring. Hardware fills the buffer and reports completion. An interrupt schedules NAPI, Linux's budgeted network poller, which reaps packets and replenishes the ring. Each socket buffer head needs roughly 2.5 kilobytes. Dev-alloc SKB takes fragments from a shared per CPU page frag cache. Ring A, Ring B, monitor traffic, and unrelated networking can occupy the same backing page. When all but one fragment are freed, that survivor still pins the entire page. Repeating this across a bounded rotating inventory grows physical backing without losing a logical buffer. Patch 1 fixes a separate alignment error. The driver allocates extra room for 128-byte alignment, then calls skb pull to advance data. But the buffer is empty. Its length is 0, so pulling a positive distance is rejected. skb reserve is the correct operation before payload exists. It advances data and tail together while preserving usable DMA space. During normal traffic, an interrupt schedules NAPI. NAPI pulls packets in batches and eventually unmasks the source. During shutdown or recovery, ath11k disables both the external interrupt group and NAPI. The old lifecycle code always disabled the physical interrupt, even when NAPI was already off. 2 disables raised Linux's disable depth to 2. 1 enable lowered it only to 1, so interrupts remained masked. Patch 2 puts the physical transition inside the existing NAPI-enabled guard. The first disable masks, synchronizes, and turns NAPI off. A repeated disable does nothing. Enable turns NAPI on before unmasking, returning the depth to 0. This makes sequential transitions idempotent without adding concurrency synchronization. Patch 3 gives each RxDM a ring its own page frag cache. New fragments cannot share pages across rings or with unrelated network users. Before non-reset recovery tiers a ring down, ath11k now quiesces interrupt and NAPI refill. It then unmaps DMA, frees ring buffers, destroys the ID map, and finally drains that ring's cache. Reset recovery was already quiesced. Together, the patches fix alignment, make sequential lifecycle transitions repeatable, and isolate receive buffer lifetimes. Buffer sizes, ring sizes, and per buffer DMA mapping do not change. Tested at HB memory stayed bounded. Same ring lifetime variation can remain. PCI and isolated non-reset recovery still need runtime coverage.